I watched The Social Dilemma, and then um, I was recommended this show called Next that I can't remember where it was like aired. It was on TV. It was like a series on TV, um, and it's about AI and essentially like yeah, like the idea of building a super intelligence that uh, basically got out of its shell. Like they tried to like box it in and keep it isolated, but it managed to manipulate the people like within the that were inside its box, like communicating with it, and managed to manipulate them to let it get out.
Oh,
And then it got out onto the internet, and then it basically like started like some people figured out that it existed and what was going on, and it actually got them killed. Like because it basically like somehow infiltrated like all devices on the planet and could get into like your smart car or like it was just like always listening to you on your phone. Like um, it had access to like security cameras all over cities and stuff like that. It was like it was a pretty great story. I thought, but it was just a prime example of why people, like everyday people, don't really understand AI in like a real like implication. And I mean, this is exactly what people think would happen if like we built some sort of super intelligent AI. This is exactly like the scenario that everybody imagines, and it's just like it's a cool story, but
yeah.
it's not good for the image of AI at all.
Well,
You know?
that brings a good question though, right? So, if I'm not mistaken, there's kind of a separation between like AGI, artificial general intelligence, and then
Right.
also what we have now are essentially classification intelligence, let's call it, or whatever. Or
Right. So yeah, that's really the interesting thing to like try to explain to people is um when I try to tell people that I work in AI, their instinctive reaction is to like reference some pop culture media thing that they've heard of, um, and try to basically be like, "Oh, isn't that dangerous? You want to build like an artificial human or something like that?" And it's just like that doesn't exist as science fiction. There are branches of research within artificial intelligence that are trying to achieve AGI. Um, but I think the real problem comes with the naming convention. I mean, like artificial intelligence just gets slapped on everything because it's a buzzword, right? I
like
mean,
like crypto
it
was during the blockchain boom.
exactly, yeah. It's like artificial intelligence is like a very vague, just like generalization of what like the kind of algorithms used in that field, but they're not like using the term intelligence just in any sense just implies like cognitive thought to most people. It only really the naming convention only really makes sense if you have a different definition for like intelligence. Um, like uh, my biggest problem with it is that the definition of intelligence that's used for artificial intelligence is uh, like mimicking intelligent behaviors. It's not intelligence per se. It's just the mimicking of, like when we build an AI that can recognize cats and dogs or any kind of classification problem. That's a intelligent behavior because you and I can do that really easily. We can look at something and we can tell right away that that's what that is. So to train a computer to do that it's not actually understanding a cat and a dog in the same way that you and I understand a cat and a dog. It's understanding it in a different way that's more artificial, but the behavior that it exhibits is intelligent in some sense of the word, and that's why we assign artificial intelligence to the term, but like the big problem with that is just that people don't really get that it's not like when you say intelligence, you're not necessarily referring to like consciousness, like real human thinking. That's not necessarily what it is in that definition of the word,
Yeah, because that would imply that we actually know what consciousness is, and even
which we
the
do not.
no, oh, we are so far. Like
So that, yeah, it's like,
yeah, the common like kind of thread with neuroscience, or not common thread, but one of the main kind of like mainstream thoughts, which I disagree with wholeheartedly, is that consciousness is just neurological firings, and that just does not conflate with certain human experiences that have occurred throughout time. Um, for them to just be neurological firings, I think is just
right,
a deconstructionist view. But what you're saying with artificial intelligence and essentially, you know, mimicking the behaviors of intelligent life forms, it to me it almost sounds like, and this might be a poor metaphor, but it's like you have a disease and you're just mimicking the symptoms of the disease to try to say, hey, this is the same disease. But it's like, no,
yeah,
you're just replicating the output. But the real thing that's occurring, the disease
yeah,
itself, isn't what's happening.
like, like I guess, yeah, that's a good example. If you if you can think of it like that pretty well. But I think like um, you know, when you and I recognize like what we see as a certain object, you know, we do that through a completely different process than the way, you know, a computer might do it. I mean, technically, you don't know what the neural network is actually thinking for that process, but the general idea is like, because I mean, you and I can see, and this is the big distinction between, this is why there is a distinction between the way that we process intelligence behaviors versus the way that artificial intelligent machines process those behaviors, is because when you and I see something for the first time, you know, if I see an elephant for the first time, um, and I don't know what an elephant is, I'm not going to know. And I'm going to ask somebody, I'm going to be like, what is that? And I'm going to say, that's an elephant. And for the rest of my life, if I see anything like that, I will know instantly it's an elephant. If you, but the same is not, it's not the same for computers. You know, if you're training a neural network to recognize images, I can't show it one image of something and be like, that's a dog. And then for every picture of a dog it ever sees, it'll know that that's a dog. That's not the way it works. So that right there is enough distinction for you for to make the point that they're not the process for exhibiting that intelligent behavior is not the same, and that has to do with like like our process of thinking, like the way our brains work is just like bounds ahead of anything that could possibly resemble intelligence. Like, and so when people try to like claim that something is intelligent, like human intelligence, it's not. You just, there's no argument there. It's not. It's mimicking intelligence. If you stack a bunch of different like mimicking behaviors on top of one like robotic system or something and try to claim that it's intelligent, you know, it, people might look at it and be like, oh wow, it's speaking to me, it's like making coherent sentences, it's recognizing objects, but like that doesn't necessarily mean it's like intelligent like in the way that we are.
It's like
It's
the
just
Turing test.
it's just it yeah, it's just faking it until it makes it, you know.
Yeah, and you know what you mentioned about the kind of elephantness, right? Philosophically, if I'm not mistaken, it's called like qualia, so like the essence of something. So like you have a tree. What makes a tree a tree? It's the treeness of the tree and that essence, right? And mimicking that with code at the moment, right? Today, I'm not sure how close you can get, but that essenceness, and then abstracting that out across multiple situations, it's almost like you can get to a certain point, from what I understand with machine learning, where you can kind of have it go a little outside of the bounds of what it's been trained on. But you know, as soon as it sees something that's not as tree-like as what it was trained on, it's not going to recognize it, even if
Right.
it's
That
still a
and
tree.
that's the reason when you're training neural networks that you need so much data. That's why they require so much data because the only way they're basically really advanced pattern recognizers, and the only way to build this advanced pattern recognizing techniques is to show them lots and lots of variations. If you wanted to recognize trees, I can't show it one tree like I would show you one tree and you would know instantly, um, because your brain doesn't work the same way. Like with a neural network, you have to show it millions of images of trees, and it looks at all those millions of images of trees and just tries to find patterns in all of them that it can use to distinguish if it's a tree or not. But it can't do it just based on one image alone. And that's and some people consider that like if we ever got to that point of artificial intelligence again, like if we ever got to that point of building a system that could do that, we would be pretty much on track to building an artificially general intelligent system.
So what do you think the
Because
timeline on that is?
I don't personally, I don't believe it. Uh, that's kind of an
Thought stream.
that was a technical difficulty, I guess. But
Elon Musk is
so
trying to fucking cancel us.
he was trying to keep me down, you know, keep these opinions to myself. But no, I personally don't think that we can reach an artificial general intelligence. Um, at least depending on the way you interpret general intelligence. Um, so if you consider building an AGI system as building a digital replica of the human brain and the human consciousness, I don't think that's achievable. At least while we don't understand our own brains completely and don't understand consciousness like really at all. I don't think it's achievable. If you consider it building a system that can operate on multiple input and output spaces, then I think that's much more achievable. And there's a lot of good research that's already being done um, moving towards that goal. OpenAI has done a lot of work moving towards that in terms of generalizing along lots of different input output spaces. Um, but I think that's the most achievable goal. And I guess what I mean by that is, if you think about the way that you perceive and interact with your world, you don't operate on one input output space. You don't simply, you can do more than just, read a book and then write a book, right? You can do more than just see an image and recognize what that is, right? And that's what most AI systems, pretty much all AI systems that exist today, that's what they do. They operate on one input, one output space. They look at images, classify them. They read text, generate new text. There is no system right now that can take text and then write you a new book, but that can also look at images, classify them, uh, that can I mean, basically like there's no system that can do multiple different types of input and output spaces. Um, at least in like the realm of like almost different senses, because we have different models to do those sorts of things. Um, but like when bringing it back to like OpenAI and the great work that they've done moving towards that, like a lot of their really advanced models, like you've heard of the GPT models, GPT-2, and then more recently GPT-3, that they released a little while ago. Um, that model works in the human in the language space. It's a language model, but it can do lots of different things within the realm of language. It can summarize, it can generate text, it can answer questions, it can do a lot of things within that one space. But for example, like it can't look at images, right? And I think that would be like if you can build a model that can work in multiple different realms of input output spaces, I think that would be a huge leap forward um, in terms of an AGI system. I think that's really like the holy grail that people are moving towards. It's just we don't know how to do it because we have different models for all sorts of things. Um, we have conv nets for images. We have uh, LSTMs and more recently transformers for language. We have um, there's tons of different models for different, and we specify them for different realms um, of operation, essentially.
Yeah, and I mean, the problem I think what's going to happen is essentially we're going through some sort of electrical revolution. We just discovered electricity of AI. Back in the 70s, we thought,
Yeah,
oh, we're going to come up with AI. We're going to be able to, propel forward with it. And then we hit a roadblock, and that roadblock from image recognition, or I think like self driving and stuff, and robots with vision was essentially you have to tell the vision algorithm where it is in the world and its position, and that philosophically that was like a huge breakthrough because it's like, oh, perception, it depends on how you orient yourself in the world for your perception to be outside of that, right? So I think we're going to go through a huge transition, which we already have seen, the AI boom, right? But it's only going to be these siloed individual tasks, these category of tasks, as you're saying, text processing, image recognition. Now, sure, you can bring those, let's say, together and say, hey, I have some of this model and some of this model, and together they can do two things. But I think what you're also alluding to, it's like these are still two separate models. Having the same neural network do multiple things,
exactly.
we can't. I mean, in the
Yeah,
human brain, we have neurological networks essentially, but they also share in the same tasks. So it's more
yeah,
akin to a CPU running code.
yeah.
But
Essentially, like, I mean, you could argue there's different areas of the brain that process different kinds of information. You have different lobes, you have uh, different areas of the brain that all do somewhat different things as far as we can tell. But um, pretty much your brain is one model. Even though different parts of your brain might process different things, they all work together to do that. One might be more responsible than something for the other, but they're all interconnected and they all work together in just processing what is your world. Um, what you're referring to, like basically stacking different models to try to mimic that that cohesiveness of different areas of operation. That's essentially, I mean, that could fool a lot of people into thinking that it's a really intelligent system, but it's a fake. I mean, in terms of like building like an actual generally intelligent system. Um, but I actually did see a paper recently. I read it the other day um, about somebody who, I don't think it was an individual person, but it was a research team that used transformers to classify images. Um, and traditionally, image classification is has been ruled by the convolutional neural net. I mean, since like AlexNet came out in 2012 and really showed that convolutional nets do this do image processing of any kind very well. They've kind of had the the show for images for like almost 10 years now. But this paper that I read the other day showed how they could use transformers to build image classifiers that were on par with ConvNets, but also took uh, considerably less resources to train, which is a big thing to take into consideration. Um, and that was really interesting because transformers like GPT-2 and GPT-3 were transformers. Those are they basically like OpenAI took the transformer model and scaled it way up, gave it lots of data, specifically um, on text so that they could train their language model. Um, but the actual architecture for transformers is the same. And these people basically, this team basically took uh, a transformer model that you could train for a language model, and they trained it to classify images. They used a specific technique to process the images so that the transformer could take it, because the way that transformers process input data versus the way a convolutional net can process input data is very different. I mean, convolutional nets are essentially built to process image data, um, whereas a transformer is a sequence model, essentially meaning like that it looks at a sequence of inputs, and uh, it reasons about them in the form of a sequence. Um, so processing an image into a sequence for the transformer to understand requires its own challenges. But I mean, you could consider that the like that's not really what's important actually is because I mean you could argue that your brain or sorry you could argue that your eyes are the way that like the pre-processing for your brain in terms of images that you see, right? um, so I mean I thought it was a pretty incredible paper, showing that they can actually do that, and I think it would be really amazing. I don't know how doable it would be, but I think it would be really amazing if somebody were to train a transformer to uh, classify images or something like that, and also process language data. I think, and that would be amazing. Um, that would really, I think that would really say something about transformers. I don't know how doable that is, because they are very different spaces of operation, but I think that would be really something.
I'm definitely out of my expertise with that level. I mean, I know some stuff that we shared a common AI course in college, and I got through it. Like I did fine. Greer was like, "Ah, this is easy stuff. What about the real stuff?" So I'm just like, "Ah, nah, yeah, that's cool stuff." But with the transformer thing, what you're talking about, having it um, deal with image and text, I I wonder if that's even like, is it even possible? Like, is it would the model be
Yeah,
exponentially larger, or is it kind of like almost, you know, like water going down a stream? Like, there's only so many ways it can kind of go through paths, and at some point, would the model that you create, would it just become what we were talking about, where you just, let's say you have two transformer models, one is text based, one is image based, and it just kind of like meshes together, versus it being like kind of shared processing. I'm not sure if I have that.
right. So I what I'm referring to with it would be if you could train one transformer model, and to train it, you would give it image sequences, and then you could also give it language sequences, and it would be able to process them uh, like within the same model. That would be, I don't know if it's possible. I mean, I'm pretty sure somebody might try to do that. Um, and if they could do it, it would be really incredible. Um, but it is a question of like whether that is possible because, um, I mean, in whether you would have to basically make a giant model that could do that, or that could even do that, is uh, not really certain. So what OpenAI did when they introduced GPT-2 and GPT-3 for language is they really showed that transformers generalize more the larger they get and the more data they have. And that's kind of a trend across deep learning as a whole. But they really showed that transformers are a really revolutionary architecture if scaled up and given enough data. Um, and so, I mean, it might be possible to scale up a transformer model of some kind and give it enough data of in different input spaces, for it to generalize across both. I don't know how doable that would actually be, um,
Huh.
and whether you would be able to actually figure out if, um, like you're saying, it would be one model, but whether the model itself would actually sort of learn to partition parts of itself for different areas of operation. Basically, like if it would learn how to, that would be pretty incredible. If you had a large enough model that learned how to section off itself for like processing the image sequences and then processing the language, um, which would be incredible on its own, or if it would be able to process them as one meshed, basically like understand how to how to relate image sequences with language data. I don't even know if that's possible, but I mean,
I mean,
it's cool to think about, and it would be really incredible to see.
we've seen crazy stuff when we've had like I forget the the background and the resources on it, but I remember years ago I saw they trained this AI model to design a CPU, and the CPU like
Yeah,
high level CPU designers are like, what the fuck is this thing? And it was unbelievably efficient at what it trained it to do, but no one could follow like why it made the architectural decisions it made. So it might be something like that where it does this cross domain jump where everyone's like, how the fuck do these things relate? But in the final analysis, it works out. I mean, part of the
yeah,
thing about higher intelligence, people with higher intelligence, is once they learn one domain, they'll be able to take those lessons, abstract those out, and then go cross domain. So that's why someone who may be successful in one field it might be quicker for them to be successful in another because they take all the essentially lessons they've learned in the other one. It's like with you or I, right? If let's say you learn something in software development like heavily, and then you go to let's say I don't know, IT, right? I mean, they're closely related, but let's say some more distant field of IT that isn't related, you will then be able to like learn faster than someone who just started at IT and never touched it because you're like, oh, here's things that relate. And then sometimes you might be able to go to something like, I don't know, biology or something and then see because there's actually some really good systems within biology where you can relate, oh, how a cell works is similar to software development system, how the systems
right,
engineering works.
right. Yeah, that would be really interesting to see.